Hey, Shannon here. Happy summer. It's a beautiful August day out here in Pennsylvania, and hope everybody's been enjoying their summer. It's been an interesting year to say the least, and I'm super excited that our PIAA announced that they're going to go ahead with allowing high school sports to happen. So that's exciting for all. Being a parent, being a coach, being a physiologist, and just a resident and former PIAA athlete. And it's very exciting for the kids. I know they were pretty upset about last year. So nice that the kids will be able to compete this season. Very exciting. So on that note, I figured I would discuss something that, maybe some administrators, some coaches, some organizations, athletic directors, various people, who are the powers that be involved in charge of decision making and how do we resume sports, and something that has been on my mind since all of this madness happening in 2020 is what's going to happen when sports resume. There's a lot of confusion, there's a lot of information out there, and nobody really seems to have a full grasp on what's the best thing to do. I figured that I would discuss my concerns as an expert human performance physiologist. Over the last 20 years, been working with, many of the world's top coaches and athletes, and also being an elite athlete myself, still competing at some level. I thought I would discuss the physiology of mask wearing during exercise. There's some organizations that are requiring people to wear masks during exercise, during indoor activity, during outdoor activity. So I thought I would discuss the physiology of what's going on there. So, maybe the powers that be can make some informed decisions before, mandating or requiring people and adults, recreational or, college youth, any level athlete or person exercising. They may want to consider a few factors. First off, being that the masks that the general public is wearing, mostly your cotton masks made up of, some fancy, team or whatever saying on it and, whatnot, or paper, they are actually not considered proper rebreathing devices, which means that they are not quality controlled to make the environment in which you inhale, the environment, the air concentration, the levels within that mask that you're breathing out and breathing in, it's not actually controlled, or they're not considered proper rebreathing devices when the air is not controlled to be of safe levels for human inhalation or breathing in. So, my concern with that as a physiologist is that, essentially understanding, the physiological ramifications and adverse effects of, not only at rest, but when you are exercising, that environment, when you're not wearing a proper rebreathing device, is amplified even greater. My main concern is the exposure to carbon dioxide and the rebreathing of high levels, toxic levels of carbon dioxide when you are not wearing a rebreathing device. Under normal conditions, say at rest, your respiratory rate, or the amount of times you breathe in and out per minute, is generally around 12 to 20 breaths per minute. So depending on your fitness levels, depending on your underlying health, whether you have something that's going to inhibit your ability to transport oxygen, whether you have a lung condition, asthma, things like that, your resting respiratory rate is going to be increased the human body is the most amazing machine there is, and it has numerous feedback systems to help us maintain what we call homeostasis, or balance. And being a human and functioning optimally is all about homeostasis. And our body has all of these wonderful mechanisms, receptors, sensors, to compensate for challenges to homeostasis, or say in a situation where we are not breathing, inhaling the composition of air in which we evolved to breathe, which we evolved in order to maintain our homeostasis. Humans are very resilient. We're not going to die right away when we are compromised, but depending on your underlying health, your underlying fitness, it will depend on the symptoms, and how you manage those challenges to homeostasis is going to depend on your underlying health. So under normal conditions, as I said, our respiratory rate is somewhere between 12 and 20 breaths per minute, and that will increase as the demand for oxygen increases. So when we start exercising, the demand for oxygen is going to increase to our, we need to get oxygen and we need energy to the working muscles. So our respiration rate, in order to get more oxygen, we have to breathe more times a minute. So our rate in which we're receiving oxygen to our working muscles is going to increase to help meet that demand. So that's a beautiful feedback mechanism to help us perform work. During exercise, depending on the intensity, your breathing rate can increase 3 to 6 times resting rates. So what that means is that the rate at which you're breathing in increases, but also the rate at which you're breathing out increases. And your typical outdoor air under normal conditions, outside, well ventilated spaces, outdoor air, you're going to have carbon dioxide concentrations of approximately 0.03 to 0.04%. So that's our normal breathing, inhaling carbon dioxide levels is going to be right around that level. And as the carbon dioxide levels increase, there's going to be various feedback mechanisms, compensations that are going to happen in our body to try to maintain our homeostasis, our balance. It's all about maintaining homeostasis. And the carbon dioxide, it is a normal metabolic product. It accumulates in the body if it's produced faster than it's cleared, and we clear most of our carbon dioxide by increasing our respiration rate or breathing out more, exhalation, ventilating. But if we're in in a space where ventilation is poor air quality, and then you're breathing your carbon dioxide into a non-rebreathing device, then you're also exposing yourself to poor air quality. The carbon dioxide we breathe out is approximately 4%. So again, that's 100 times higher than what we have evolved to breathe in. So again, expired air is 100 times higher the levels of carbon dioxide that we are meant to breathe in at normal safe levels. As our carbon dioxide breathing in, the amount we breathe in increases, you will notice some symptoms. A few hours, at rest, you might have some drowsiness, headaches, labored breathing, reduced mental acuity, reduced mental performance, and so on. As we get up to the 3% levels, the levels in which we are breathing out, this can cause severe respiratory acidosis, metabolic acidosis, which is, toxicity in our blood. We become toxic. We can become unconscious, and we can also die from these breathing in such high levels of carbon dioxide. And when you are exercising, those levels that you're breathing in, if you're wearing a mask that's not a rebreathing device, are going to become toxic within, less than 2 minutes. So you really should be aware of, if you have any of these symptoms while mask wearing. Most likely it's going to be because of the carbon dioxide levels becoming a challenge to your homeostasis. And you should really start paying attention to body cues, things like that. Again, there's going to be numerous effects and symptoms depending on your underlying health condition. But as you exercise, as the intensity increases, your body's going to try to compensate for respiratory acidosis by increasing your ventilation rate, increasing the number of times you breathe per minute. But if you're not wearing a proper rebreathing device and you're trapping in that carbon dioxide, which your body's trying to compensate for because it has too much in its blood already and it can't get rid of it because you have nowhere to breathe it out, then you're only going to exacerbate the problem. So you're kind of stuck in a catch-22. Your body is trying to compensate for the high levels of carbon dioxide in the blood, but then you increase your breathing and then you're only rebreathing in a lot more carbon dioxide. So that's going to put most athletes in a very compromising position. And then, eventually you're going to go into what we call metabolic acidosis. Metabolic acidosis occurs when there's an imbalance in your body's acid-base balance. So again, all of our feedback systems to fight this change in our homeostasis, our drop in our body's pH, becoming more acidic, we are trying to breathe out that carbon dioxide. We're trying to get our body back in balance. We're trying to get rid of the things that are making us acidic. And if you are chronically, if your acid-base balance is chronically off, then you are likely to exhibit symptoms of heart palpitations, joint pain, bone pain, altered mental status, vomiting, abdominal pain, muscle weakness, and ultimately reduced kidney function, because your kidneys are going to compensate to try to make up for that acidic and produce more bicarbonate. So they're kind of working overtime to try to compensate for metabolic acidosis. But meanwhile, you're not helping your body, because all you're doing is breathing in more toxic air. So ultimately, this is going to be very challenging to homeostasis, not only on the short term, but long term. When you are stuck in this negative feedback loop and you are breathing and rebreathing toxic levels of carbon dioxide, which occurs within minutes of exercising with a mask on, you are really putting yourself in a compromising position. So, my stance as an expert physiologist, I would highly and absolutely contraindicate mask wearing during exercise at any point, at any level, at any intensity. It is not safe, and it is not good for your homeostasis, acute symptoms, and even can cause chronic conditions and even death. Unconsciousness, going unconscious during an athletic activity is really not recommended, because that's how you get concussions and you fall over. I've actually done that numerous times. I've had a bout of vasovagal syndrome where I pass out in the middle of runs, in the middle of bike rides, and that's how I've gotten many concussions. So, it's really not a thing you want to really consider if you are someone making those decisions. So I think you get the point on my stance and my recommendations as a physiologist, the contraindications to exercising while, not wearing a proper rebreathing device is very dangerous, and putting people at an increased risk of many possible adverse effects. I do want to touch on the physiology of mask wearing with two other vital gases that are really important for human homeostasis, and that is going to be oxygen and nitric oxide, and how not when you're wearing a mask that's not going to control for that environment of inhaled air. Again, talked about humans, we've evolved all of our systems to ensure optimal oxygenation, oxygen of our cells, in all of our processes. That's how we've evolved. The Homo sapiens, we've evolved to carry oxygen. And in order to do that, there's, complex systems that are involved. There's feedback systems, but, generally oxygen is delivered via our lungs. We breathe it in, and oxygen is transported via our red blood cells. And then, through our vascular system, those red blood cells, those oxygen carrying critters, those nice oxygen carrying cells are carried through our vascular system, and then our heart is what pumps it out. So when we exercise, not only does our breathing rate increase, but our heart rate increases to meet increased demands for oxygen. And it's the precise balance and establishment of these systems, our entire body systems, all of these feedback loops, all of these systems, all they're doing, they're always working to combat challenges to homeostasis, no matter what it is, whether it's compromised air or oxidative stress, whatever it may be. But right here I'm talking about compromised air composition, especially while exercise alone, even in a normal environment with normal air that we've evolved to breathe, exercise, when you start exercising, that's the ultimate challenge to homeostasis, because everything is off and everything is on high alert to try to manage that stress, the stress of exercise. So it's a very complex complexity of systems that need to be firing for not only maintenance of homeostasis, but also for peak performance. It is actually has been suggested that endurance running has played a significant role in the evolution of Homo sapiens, but we all know it's pretty well established all of the many positive physiological effects of aerobic exercise on preserving and enhancing our physiology, not only for general health and wellness, but also for performance purposes. So, the aerobic metabolism in Homo sapiens is extremely important. It's a big part of our evolution, and when you compromise that, you are challenging your homeostasis to many levels, even as a healthy person. Now, the more challenges you have to homeostasis at rest, meaning disease states, underlying conditions, then all of these things I'm talking about are going to be exacerbated even more. All of the challenges to your homeostasis are going to be exacerbated even more when you are not breathing the normal composition of air that our cells have evolved to breathe, to essentially operate and maintain our homeostasis. Normal oxygen in the air that we inhale is about 20 to 21%. Again, mask wearing without a proper rebreathing device increases oxygen levels to around 17 to 18%. And oxygen levels breathing in at around 19% is considered to be unsafe. So I'm not going to get too much into the hypoxia, because actually I'm more concerned with the carbon dioxide toxicity being a greater problem of mask wearing during exercise. But hypoxia is a really big concern as well, and many of the same symptoms, hypoxia and hypercapnia, or increased carbon dioxide in the blood, are very similar symptoms. So, the headaches, the tachycardia, increased heart rate, anxiety, confusion, and unconsciousness and death. So these are all very serious things to be considered when when you're requesting or mandating that people wear these non-rebreathing devices during exercise and activity, and also, especially if the person, even at rest, if you have compromised health, this is not recommended. You already are having challenges to homeostasis and breathing, and then you're putting yourself in a more compromising position. So it's not really recommended to do on a regular basis. One other nutrient I do want to touch on is nitric oxide. A lot of people, they get, oh, okay, I understand carbon dioxide and oxygen, why that might be an issue. But another important nutrient, not only for the, athletes aside, let's discuss the general population and why nitric oxide is really important. Nitric oxide is an important vasodilator. So what that means is nitric oxide, when we breathe through our nasal passages, nitric oxide is a nutrient that is going to be produced and stimulated via the nasal passages. And a vasodilator just means that it dilates our vessels to basically deliver the oxygen and nutrients we need to survive. So if we are covering our nose and we're not getting the proper composition of air, and we're limiting our nasal breathing, then we're going to be limiting our nitric oxide production in our body, and which is why some people are going to have anxiety and feelings of chest tightness if they're, maybe an essential worker, somebody has to wear a mask all day long, why they're starting to feel this maybe chest tightness and, uncomfortable feeling. It's because you're unable to vasodilate properly. Your vessels need proper nasal breathing in order to accomplish this. And one of the things of our with the nitric oxide, it helps to improve our nasal microbiome, which is important for proper lung functioning. And the nitric oxide plays a critical role in immune defense because it does regulate the nasal microbiome, the gut microbiome, and again, athletes aside, athletes and the entire general population is generally critically low on vitamin D levels, especially in areas where people don't get outside much. There's long winters. We have an issue with vitamin D. And vitamin D exposure, vitamin D absorption is a key nutrient, not only for bone health and bone strength, but also it's a key nutrient in helping to build our gut microbiome. So vitamin D is going to help increase our immunity, but it's also really key. Vitamin D is a key nutrient in proper lung functioning. So shocker, a lot of these people with these lung problems who are susceptible to respiratory illnesses, they show that they're low in vitamin D. Well, vitamin D is a critical factor in proper lung functioning. It improves the gut microbiome, which in turn helps to build your immune defenses. The vitamin D actually plays an important key role in remodeling the airways, improving lung development, improving lung strength, and also improving the respiratory immune defenses to pathogens. So, we've got this really crazy, all these feedback systems, but all these key nutrients, if they are low, you're going to make yourself more susceptible to respiratory illnesses. So, when you're asking someone to wear a non-rebreathing device, you're limiting their nitric oxide. They're already most likely low on vitamin D, so you're further exacerbating these conditions. So what happens when you are limited in nitric oxide? Your vasodilation is down, you're low in vitamin D, so your lungs and your airways look like, you know, just these like mess of a you know, plaque. They're like plaque built up, and you know, you're having a hard time breathing because your arteries and your lungs can't contract and expand easily because they're hardened. You know, without vitamin D, it's almost like they get calcified. So, you know, the vitamin D and the nitric oxide balance is a key part of not only our gut nasal microbiome, but also to lung functioning. So, you know, we're going to see, you know, again, the general population, they're not very fit for the most part. Most of them couldn't do, under normal circumstances, 5 minutes of continuous aerobic activity. You're going to have almost every person on the planet fail a forced vital capacity lung test because the fitness levels is something that needs to be addressed. But we also have all of these other factors challenging their homeostasis even more: vitamin D, nitric oxide. So, you know, my closing arguments, thoughts, suggestions, whatever you want to say, as an expert physiologist, and, you know, working in primarily high performance, but I'm also a clinical exercise physiologist. I'm also a performance enhancement, you know, ACM certified clinical exercise physiologist, performance enhancement specialist, and corrective exercise specialist. So I do work with, you know, all portions of the population, but my passion is athletics and high performance because that's really cool. I would most definitely and undeniably contraindicate mask wearing, especially if it's a non-rebreathing device, during exercise. I would contraindicate mask wearing at rest for long periods of time for those with underlying lung conditions, asthma, COPD, anything where they're already having compromised lung functioning. Anybody with low vitamin D levels would highly contraindicate against those conditions, those situations, and mask wearing and putting your, you know, additional challenges to homeostasis and breathing. So that's my tip for today. Hope you got some information out of this, and you know, if you have any other questions about this, but again, I just thought it was important to share, you know, especially as sports are resuming and, you know, there's a lot of confusion. Thought I would just shed some light onto the topic. All right, have a great day.